This video is about the Brother International Planetron VX-10 AM/FM radio plus 8-track player. I picked it up from a very nice man in Toronto, Canada. This is what I would call a novelty-style machine because it's not a regular rectangular shape. Quite the contrary, it's trying to be anything but rectangular. Novelty machines like this were a thing in the 1970s as manufacturers became more adept at making products out of molded plastic in various irregular shapes. Other novelty-style machines included the similarly styled Aquatron VX-33A and C, the Weltron Spaceball 2001, 2002, 2004, 2005, the Winford Hall TCM 5500, the Electrohome Apollo series, and many, many others. In this video, I'm going to be opening up this Planetron VX-10 and getting it to work. An 18-second message from our sponsor, Mr. Brown. Hi, this is Mr. Brown. The way YouTube's algorithm works in pushing this video onto other people's feeds, liking and subscribing are very important, but they also look at commenting as a measure of engagement. If you want to help out the channel, please like, subscribe, and comment. Thank you. A quick look at the Planetron's features and design. At its heart, the Planetron is an AM/FM radio, an 8-track stereo tape player, and an amplified speaker for an optional phonograph with the phono inputs in the rear. The function selector is a knob on the front. There's a telescoping antenna to improve radio reception on the back. To turn it on, you press the power button and the power light illuminates. There's a lamp to illuminate the radio dial as well. To conserve batteries, it only illuminates when the button is depressed and only when it's set to AM or FM. For the 8-track stereo player, there is a button to select the 4 different audio programs that are on an 8-track stereo tape cartridge. Lights 1 through 4 illuminate to indicate which program you're listening to. It's designed to operate while plugged in off 8 D-cell batteries or while plugged into your car accessory or cigarette lighter outlet. The power source is selected with a knob as well. The batteries and power cord are accessed through a panel in the back. Since batteries deplete quickly with this unit, there's a battery level meter on the front so you know when you're going to have to get 8 more batteries. Left channel, right channel balance, volume, and tone are adjusted using slider controls. This style of control was common in 1970s audio equipment. Unfortunately, the knob inserts are missing on this unit. For personal listening, there is a 1/4 inch stereo headphone jack. This size was common up to the late 1970s. The built-in speakers are on the sides and have barrel-style plugs to attach optional external speakers. So that this unit is truly portable, there's a handle on the top which becomes flush when it's not being used. On the bottom, there is a rubber suction cup to keep it steady on smooth surfaces. When I put in a tape, it plays, so the belt is still working. You get no audio, or very, very little audio. That's top volume. Let's try the radio. That's the top volume, which is nowhere near what I would expect it to be. The issues with this machine are the low volume, especially bad on tape, but also present on radio, the tape player drive belt that's near the end of its service life, and the missing inserts for the 3 knobs. But there's one more thing. It's something I noticed the first time I put in a tape. The mount that holds the tape head is made out of nylon. These mounts are notoriously prone to cracking over time. There are no replacements available, but a protective shroud is. If the shroud is glued in place over the mount, it should prevent future failure. Mine, fortunately, is still intact for now, so I gotta order a shroud. There are 4 screws under the handle. 2 at the front and 2 at the back. All 4 screws on the top of this player are the same length. The front screws are longer on the bottom. Okay. Look underneath the rubber foot and there are screws at the bottom as well. They are much shorter. They're like 1/4 inch machine screws. Let's see if I can lift off one side now. There we go. I now have access to the belt, which is right over there. The belt has not disintegrated, but it's quite limp. Really, it's a hero. It's lasted this long, and it's not turned into rubber goo. But I'm going to replace it. I don't think I have anything in stock that short. I will have to measure it, though. There's a piece of electrician's tape right over there. I have no idea whether that's OEM or not, or why they would even bother with that. I am going to be putting a quick disconnect on each speaker. But even if I wasn't, I would have to repair these wires because they were crushed during assembly, whether original manufacturer assembly or at some point between then and now. They're not quite cut all the way through, but they are cut. They're damaged. So I'm going to cut them right where the damage is. The most pressing issue on this machine is the low output from the tape player. There is no schematic diagram available for this unit that I can find. Instead, let's start with a simple block diagram. The signal travels from left to right. For the tape player, the signal starts at the tape head, where it reads magnetic patterns off audio tape. These tiny signals are amplified by the tape head preamp. The tape head preamp outputs to the selector switch, which must be in the tape position. The signal is then reduced by the volume and balance controls before being further amplified by the speaker amplifier. Finally, the signal is large enough to power the loudspeaker. The problem could be at any one or more places on the block diagram. Let's start with the tape head. There aren't that many things that can go wrong at the tape head. You can do a careful visual inspection for broken wires, but it's most likely that the tape head is out of vertical alignment so that it's not able to read the audio tracks, which are less than 1/32 of an inch or 0.8 millimeters across. Fortunately, this is easy to test. Unfortunately, it's hard to fix. A bad tape head is possible, but highly unlikely. There's the tape head right there. And this is the mount for it. And that's probably why the sound is so bad, because this is moved. I can test that hypothesis by shifting the head. See if I push on the tape head. I didn't see any breaks in the wires. No difference could be heard when changing the position of the tape head. I'm going to conclude that the problem is further downstream. Let's go back to the block diagram. What I didn't mention before is that audio stages are generally coupled together using capacitors, most often electrolytic capacitors. This is because capacitors block DC bias from one stage from interfering with the bias in the next stage. Unfortunately, electrolytic capacitors, especially old, cheaply made electrolytics, are notorious for failing. The answer to this is to replace all the electrolytics with new ones in a tedious process called recapping. What I foresee being difficult, this wheel on the tuner covers some of the printed circuit board. I can try to solder around this, but it will be a problem for a couple of capacitors in this area. That risks damaging this with the side of the soldering iron if I'm not careful, or breaking the string, again if I'm not careful, or I'll have to take that off. The string will fall off all the pulleys, and it will have to be restrung. Not impossible, but time-consuming. We just need one weak capacitor on each side to reduce the volume by a lot. And I'm betting that that's going to fix the volume problem. Of course, I could be betting wrong, but I'm not betting a lot. Just a handful of capacitors. 23 capacitors were replaced on the main printed circuit board and one on the power supply board for a total of 24 pieces. When replacing electrolytic capacitors, be mindful of their polarity. Reversed capacitors may explode. Recapping, or pulling out about 24 capacitors off the main board, made a huge difference to the audio on one channel, but only a moderate change on the other. What I suspected was that there were capacitors that I missed, but there weren't any left to replace on the main board. Until I realized that there are capacitors hiding on the board at the front. I don't know yet how I'm going to pull this board out without having to disconnect the dial string, which I really don't want to do. 10 compressed fingers later, I was successful. It is possible to get the capacitors in. It just takes squeezing your fingers into tight spaces. Here's the updated list of electrolytic capacitors that have to be replaced. Was it worth it? Yes. Replacing those capacitors restored the volume to as it should be. I get a lot more volume now. I'll demonstrate it later. I now have a date of manufacture. I don't know if you can see on the FM multiplex chip the date code 7632, which would make it about August 1976. This could not have been manufactured before that date. That's when the chip was manufactured. I've got the dental floss going around the flywheel and around the motor, and then I just have to mark it right over there, and then I have to measure it. I'm getting 27.8 centimeters, or just about 11 inches in length, and 5 millimeters, or 0.197 inches wide for this. Shouldn't be hard to acquire. This is the dial light bulb, but it looks like it's open. It's going to get replaced, and it fits into this grommet right at the top. Just a single bulb. That's it. To get a better view of this, I'm going to take the knobs out. They generally pull out straight. And all three knobs, no, two knobs are the same. This one is different. It has no tick on it. And these, it looks like that something was glued on. I bet you they're like Weltron knobs, which I may be able to simulate with some MacTac, which I happen to have in large supply. We'll see how that looks. Maybe I can find a picture with a good close-up of the knobs so I can see what their knobs actually looked like. I'm going to change this to an LED. As a time saver on this project, I'm going to use pre-wired LEDs, that is LEDs with the resistor already included. These are 12 volt warm white 5mm, which will work for the pilot lamp. I might change these lights to LEDs, particularly the power light, because it's already getting blackened. It doesn't look like they're going to come out of those grommets nicely. Don't have to do anything about the stereo light because it's already an LED. If you remove these two screws and these two screws and these two screws, then this assembly moves forward. Then it makes it real easy to get to the LEDs. Well, get to the bulbs and turn them into LEDs. 5mm LED goes into the opening just fine, and it's snug. You won't need any glue or silicone to keep it in. I've got LEDs now. Not too bright. Actually, they're quite bright when you're on axis like that. But that's perfect because it will light up the faceplate. For the new belt and the shroud for the tape head, that's going to take a few weeks, maybe months, depending on Canada Post. There's a postal strike going on, and nothing from abroad is entering the country by postal services. I guess that will be in the next video. I hope you enjoyed this one. If you did, please give it a thumbs up, and subscribe to Mr. Brown's Basement for more interesting and unusual videos.